I'm Sylvie Joussaume and I'm a French climate modeling scientist. I am within CNRS and I work within Institut Pierre Simon Laplace, which is a big institution. I'm a researcher within CNRS. CNRS is the French National Research Center for Scientific Research, which is one of the biggest institutions in Europe for research.
Okay, is this climate research?
No. CNRS is all the disciplines.
Okay.
It's really multidisciplinary, and but inside that there are some researchers that are under the climate, which work for climate.
Okay, and at the conference in Trieste we are now, here, what is your main goal? What do you hope to achieve at this conference?
I mean, I went there because I think that the e-infrastructure, so the infrastructures related to the computing, the network, are very important for our field. So I went there to hear what the colleagues were going to say, but also to really show this importance that it has for climate modeling. So to also show what we do in Europe within a network which is called INES, European Network for Earth System Modeling, which deals with climate models.
Okay, and in your opinion, is there one infrastructure is there a best practice to use infrastructures for climate change, or is it multidisciplinary? There's many different types of e-infrastructures to use.
Yes, there are different aspects. The first one, the key one, is to have access to high-performance computing. Without the computers, you can't do those simulations. So all the bases of the science, which are the projections for future climate change, they are done using quite high performance computers, and so for us it's one of the key targets. But then that's one part of the activity. The other part of activity is also to develop those models, and we also consider them as an e-infrastructure. I mean, the codes themselves are part of the infrastructure, and all the dissemination of the data, because this is an activity where the data that are provided or that are issued from the simulations are then widely used by a wide range of communities to help infer what are the impacts of climate change and to help decision.
And what do you mean by dissemination? Dissemination to who exactly? Scientists, the public, or both? First level is to the scientist, because then it's really then from the science that you can then go a step further to the decision. But it's the climate modeling will be the base for the scientists that will do impacts, like impacts on agriculture, on water, on health. And from that, you go more directly to the practitioners or decision makers. Okay. And do you use cloud computing in your research at all?
No, I must say that for me it's not yet fully a reality or something that I use. It's not going to solve our issue of doing the simulations themselves. So we need high performance computing, but the cloud computing might help maybe to deal with this amount of data, which is going to be more and more distributed, and to ease access and to ease computations around the data that may be needed to have a better information or better adapted to the users.
And in your opinion, what is cloud computing?
I see it as a use of computing quite diffuse. You don't know exactly where, you just plug and you have access to some computing facility, but you don't know where. It's like electricity. I don't know why it is called cloud. For us it's a bit misleading, because cloud is also something we are working on as part of the climate.
Sure, the clouds,
so
the clouds
cloud computing for us is completely ambiguous because of that.
And you mentioned high-performance computing. Do you include supercomputers or also quick computing?
Yes. No, it's really supercomputers that we are really quite favoring. It's very difficult when you have a climate model to distribute it on several computers, because you have those fields. You need to have a lot of exchange between different points of the atmosphere, between atmosphere, ocean, and that does not go well with something which is distributed on several computers.
It needs to be in one main system to analyze that.
Yeah.
And From your presentation, I noticed there are many different factors involved, of course, with climate change. But is there an overall objective or goal for climate scientists right now in terms of computation? Is there a particular challenge you're trying to solve that will really give you a next step to predicting the climate in the future?
We have two, but they are completely related. We have the feeling that we should go towards a higher resolution to be more adapted to provide information which is more relevant for society, but that needs to revisit the models to improve completely the way we represent processes like clouds, water, precipitation, and all these processes. But at the same time, this is also highly dependent on the computers, and now the future of the computers is more and more to have a high number of processors, and this is much more difficult to be used by our field, and this asks a lot of questions of how to do that, how to deal with that, how to deal with the data, and how to keep the highest performance as possible.
Okay, thank you for your time.